Hello, BGSU Center for Undergraduate Research and Scholarship. My name is Evelyn Maciejewski, and today I will be giving you my presentation on spatial and temporal distribution of zooplankton in Sandusky Bay and implications for larval walleye foraging and growth. I was the main undergraduate student working on the project, but I also got help from PhD candidate Chris Kemp and my mentor Jeff Miner. For the abstract, larval fishes, which are generally 10 to 15 millimeters in length, not very large, must transition from feeding on the yolk of the egg to foraging for zooplankton. Because these larval fishes must transition successfully in a short period of time, typically days, the availability of prey is considered to be very important. This availability need has led to the mismatch hypothesis, describing survivorship value of making the transition to extragenous feeding at the time when prey zooplankton are at the highest density. Through the dissertation research by PhD candidate Chris Kemp, who is trying to understand the ecological relationships between a local fish species of importance, the walleye, their prey, and the heterogeneity, I've identified the zooplankton species and larval fishes in a grid throughout the nursery habitat of the upper Sandusky Bay region. As you can see from this map over here, basically, Chris focused on the Bay area as well as parts of the river. For this research, they collected zooplankton, prey, and larval fishes in a grid throughout the nursery habitat of the upper Sandusky Bay. Mr. Kemp processed all the larval fish collections, looking for walleye in the zooplankton samples when walleye were at peak abundance, while I identified the zooplankton species and distribution of them during the spring of 2018 within the Sandusky Bay. My research questions will focus on the overall spatial and temporal distribution of zooplankton species and the distributions of them during the spring of 2018. Focus on the overall spatial and temporal distribution of zooplankton in this system through the spring when larval fishes are present. I have also compared my samples results to that of the two other data sets looked over by other students as well to see if other times within the spring these concentrations are slightly different. So mainly my research question and objectives were, with my research question being, does heterogeneity in the community composition and density of prey zooplankton occur in an important survey habitat for larval walleye? My first objective mainly was to quantify zooplankton density by species from a set of samples collected through time and across Sandusky Bay. So objective 2 was to determine if heterogeneity in zooplankton distribution correlates with larval walleye distribution to relate zooplankton density with potential for zooplankton growth. So now with regards to the experiment, my materials and methods were initially back in May and June of 2018, Chris Kemp went out to the upper Sandusky Bay region and proceeded to collect samples within this grid pattern to see if the area or different times during these months would impact the distribution of zooplankton. We have replicate zooplankton samples from these sites in the upper Sandusky Bay region collected in May and June of 2018, with a total of 72 samples within 6 weeks at 6 locations, with each having 2 replications. I then proceeded to start of the semester to look at these samples collected within this time frame to identify the zooplankton species within those samples and to determine the total amount of zooplankton within these samples below is the samples collected and equipment I used. So mainly, this first picture here is showing all our samples that were processed. This is the microscope I used. I used at the magnification at 3x just to make sure I was doing it accurately each time. And then here is my cylinder that I used to dilute the samples. So with regards to the data, so tables 1 through 4, this is showing the zooplankton density from a variety of locations within the Sandusky Bay region itself. So this first graph right here is showing you the zooplankton density on the first date, which was May 16th, 2018. Mainly the zooplankton, on the side, the zooplankton density is in milliliters, and this is by location within the bay itself. So as you can see here, that you typically, like in this area, the Sandusky Bay region had the highest amount of zooplankton within it, whereas compared to the left side of the bay, as well as over here, and even in the river itself, there was less zooplankton. So basically it's telling us that the bay itself during May 16th has the highest amount of zooplankton, so this is where you would want to study with walleye, as well as with the zooplankton. This is where you would want to collect data and study. And then the next graph is basically the zooplankton on the next date we had, which was May 28th, 2018. As you can see here, the distributions actually are very, like they're closer. But the same still can be said about the middle part of the bay region, having the highest amount of zooplankton density per milliliter. And as you can see here, still the side of the bay and the river area on the left side still don't have a significant amount of zooplankton compared to the middle of the bay. So this basically shows me from this graph to this graph, it's showing me that here there's not much diversity and density of zooplankton, but with here, it's getting warmer typically, so I feel like that is the reason for increased zooplankton growth. And it's before the larval walleye are done with their yolk sac and start eating those zooplankton populations. So this next graph is showing us on June 7th, 2018. And as you can see here, it's still kind of decent concentrations all over the bay, except right here, this region. As you can tell by this part of it, it's starting to become insignificant again as it was up here. So like the middle part of the bay again, this part of the bay again, still has the highest concentrations, with this this left side a little bit more so on the upper part of it. But in general, even though it's getting warmer, you would think there would just be more diversity because of this. I don't think this is I think the reason why this is happening, this decrease, as it did appear, is because of the larval walleye consuming them. And then the last graph is showing it from our last date, which is June 20th, 2018. And as you can see here, mainly the highest density was in the northern part of the bay. And I mean, yes, the middle part of the bay still had the highest density of zooplankton, but honestly, this side and the river started to have nothing really. So basically it shows that the larval walleye consumed the zooplankton populations, giving us an idea of where the walleye are at specific times of the spring. So as you can see by these pictures are from various zooplankton as identified. This is a busmina, this was the most common I found. This was a cyclopod, Delphina, and calanoid. So basically these two were the most common, with this one being the third most common that I found within my samples that I analyzed. So conclusions from this. So what can we draw from this? So basically what I found, the zooplankton that were mainly found in each sample were Delphina, Cyclo, and Bosmina, with a limited amount of calanoid. So the late May samples, mainly Delphina, Cyclo, and Bosmina, with minimal amounts of various other samples, various other zooplankton were present. So that correlates with my graphs. And in the early June samples, I found that there was mainly Delphina and Busmina with no calanoid or cyclopod. And then the late June samples, there were high concentrations of Delphina and Busmina, but more cyclo and limited calanoid populations. So in conclusion, I believe my hypothesis was proven right, that I thought that there would be more zooplankton populations once it got initially warmer, as it did with these graphs, than at the beginning of the spring and the end of the spring. And that also concludes for us where those larval walleye are within the bay and river, and where we should collect samples of larval walleye to examine in the future. So conclusion. So basically, that conclusion, what I can improve upon, I think, is that we could go out more frequently to these regions of the bay to get a more generalized picture of basically what is going on within this region. Also, I feel that if we could get more samples within the river and more frequently as well, that would give me a better picture of what's going on within the river itself during these time periods to get a better depiction of the exact concentrations. Also, one last improvement I think we could have done is getting the exact same amount of water within each of the sample containers, because some of the sample containers didn't have as much water, they had minimal water. So I feel like if we could have the same amounts, then it would be more accurate. So just some basic things to improve upon for next time. Overall though, I think my experiment went well, and we can clearly see a trend with my data. So I hope you have a great rest of your day, and thank you, CURS, for allowing me to do this. Bye.